Hello students, today we are going to continue the same topic on sets with a few more examples and just a quick revision that we had yesterday's that we were telling that set is a collection of well-defined objects. And a set can be written in two different forms, the set builder form and the roster method. These are the two different ways in which a set can be expressed. And for today's class, we are going to see a few examples related to this concept. Before we go to today's exercise, it is always nice to have an idea about the number system that we have seen up to last year. Starting from the nursery class up to class 10, we have seen, we have heard about different kinds of numbers, and if you regroup these numbers, we are getting different groups, such as natural numbers, whole numbers, integers, rational numbers, irrational numbers, etc. So when you talk about the natural numbers, the numbers like 1, 2, 3, etc., that we are going to use to count the things will form a set, or that group or that set is known as the set of natural numbers. In other ways, these numbers are also having a word, a new name, counting numbers. The numbers meant for counting the objects. That's why that is the first group or the first set, and the symbol for the natural numbers is capital N. Then it comes the next group, the whole numbers. The numbers starting from 0 with all the natural numbers, which means 0, 1, 2, 3. All these numbers are full in form, uncut numbers. So these numbers are known as the whole numbers. The symbol for the same is doubling. Then we have another group, integers. Integers are possessing sign, the signed numbers, either positive sign or negative sign. The numbers like 0, plus 1, minus 1, plus 2, minus 2, plus 3, minus 3. So when you select all these numbers, this will be making a new group again, known as a set of integers, and the symbol is Z. Then it becomes rational numbers, all are fraction, in the form of P upon Q, where Q is not at all 0. Then every number that you take from this group will be rational, provided it is in the form of a fraction. Both the numerator and the denominators must be integers, like 1 upon 2, 7 upon 9, 6 upon 4. All these numbers will be rational numbers. But there are still another set we are having with a radical sign, like root 2, root 3, root 5. These numbers may not be having the same quality as that of a rational number. Therefore, these numbers with a radical sign, root 2, root 3, root 5, root 6, etc., known as irrational numbers. When you collect all this group, natural, whole numbers, integers, rational, irrational, in a collection, this whole collection is known as now the real numbers. The symbol is capital R. Then this year again we are going to study another set of number which will never be a real number. Real number is having a speciality, you know. When you draw a number line, these numbers you can mark on a number line. Every number, like natural number, whole number, integers, rational, irrational, you can mark on a real line, a number line. These numbers are known as real numbers because really we can represent these numbers on a number line. There are several numbers like root of -3, root of -5. This you cannot mark very easily. These numbers will form a new family known as complex numbers that we are going to see this year itself in another chapter. But today's questions will be now related to these concept numbers. That's why we have spent a few minutes over this video. Now come to today's program. Question number 1. Write down the following sets into set builder form. You can check on the green board. The first set is A is equal to set 2, 4, 6, 8. We are asked to convert that set into a set builder form. Yesterday we have seen that in the set builder form, we will never write the elements of the set. Here the elements are 2 is the first element, then 4, then 6 and 8. These elements cannot be written as such in the case of a set builder form. Then what we are going to do? Instead of this 2, 4, 6 and 8, we are going to use a variable x, which means we are going to bring a new variable x. That x will stand for this 2, this 4, this 6 and this 8. Now you see the quality, the characteristics of these numbers now 2, 4, 6, 8. All these numbers are even numbers and these numbers are below 10. Therefore the main quality for these numbers are these are even numbers less than 10. Therefore the whole set we can transform in another way. A is equal to set of x such that x is an even number less than 10. Therefore, the first kind, when you write A is equal to 2, 4, 6, 8, this set is in the set in the roster form or listing form. Whereas the same set we are going to write A is equal to set of x, where x is an even number less than 10. That is also a set. And this set is in the builder form, set builder form. Another example we can see as B. B is equal to set 1, 4, 9, 16, 25. Then so many nodes, which means this number is not getting ended by 25. It is again several out. The next number could be 36. Then it could be now 49, then it could be 64 and so on. So when you look at these numbers now, these numbers are going to be the perfect squares. Square of 1 is here, square of 2 is there, the square of 3, square of 4, square of 5. So this is a common pattern we can see here, the common nature. So that we are going to express like that, B is equal to set of x such that x is the square of a natural number. So when you speak about the square of natural number, this will include all these numbers in this family. Similarly, next example, C is equal to set A, E, I, O, U. Check these numbers once. This A, E, I, O, U, in the lower class they have learned that these are the vowels in English alphabet. Vowels. So A is a vowel, E, then I, O, and U. So the common pattern is now all these vowels are the vowels. So we can express that C is equal to set of x is that x is a vowel in English alphabet. Now comes D. D is equal to, look at the set correctly, 1 upon 2, 2 upon 3, 3 upon 4, 4 upon 5, 5 upon 6. Now you learn the properties of these numbers now. We can't say exactly using a sentence here. In this case, we are bound to make an equation which we can make, which is this line here, now 1 upon 2, then 2 upon 3, 3 upon 4, 4 upon 5, 5 upon 6. In every case, you can see this numerator is 1 less than the denominator. Or in other words, the denominator is 1 more than the numerator. That is a property. This 6 is 1 more than 5. This 5 is 1 more than 4. This 4 is 1 more than 3. So this could be the property. What property? The denominator is 1 more than the numerator. So that property we are going to write like this. D is equal to set of x such that x is equal to. So we bring an equation which we n upon n plus 1. N divided by n plus 1. Then we need to say that what is your n? N is a natural number. So this is a symbol we go for. N belongs to n, which means n is a natural number. Are we taking all the natural numbers? No. It can be maximum up to 5. Because this is 1, 2, 3, 4, 5. You don't have the number 6 or 7 in the numerator, which means we are going to make a condition again, n is less than or equal to 5. So when you write it down this way, it becomes now a set under 4. Now comes E is equal to set of February. Now learn it. What's the property of this month's February? This is only 1 month having less than 30 days in the calendar. So as a result here, now we are going to put it down. E is equal to set of x is that x is a month having less than 30 days. So what you can learn here? This left hand side is the roster form, which means the elements are written one by one. All the elements are written down. The right hand side is going to be the corresponding set. We are expressing using a variable x. So this could be the set builder form, the right hand side, and this could be the set in the roster form. Eventually, the things are same, but the pattern, the fashion will be very different. This is an exercise for you tomorrow when you come back. Rewrite the following ones into roster form, just backward. We are going to move backward direction. The first set P is equal to x such that x is the letters of the word English. Q is equal to set of x such that x is a factor of 8. R is equal to set of x such that x is the letters of the word assassination. S is equal to set of x where x is the largest flower in the world. T is equal to set of x such that x is the smallest whole number. So make a study over this question, revise it once more for tomorrow, and be present for tomorrow's class. Thank you. It's all.